Hello students, welcome to the practical demonstration session on experiment number 6, that is to find out the fiber and void fractions of a glass fiber reinforced composite, that is called as fibers reinforced plastic specimen, FRP specimen. Apparatus you needed for this experiment are: first you need high temperature furnace, that is capable to go till 800 degrees Celsius. Then you need high precision vernier caliper for accurate measurement of sample. Then you need a tongue, this is called as tongue, to hold the crucible and to keep it in a furnace. And then you need a porcelain crucible. This is made up of ceramics, that is because it should sustain high temperature. Ceramics generally have high melting point as compared to the polymers. So I will zoom this one and I will show you this. So as you can see here, this is the sample that we have used for this experiment. This is the vernier caliper, this is a tongue, and this is a crucible. This is the furnace. In this experiments we have 5 steps, so we will go now one by one. First step is to take a sample and to measure it using high precision weighing balance. This is the high precision weighing balance. That can measure weight up to 0.1 milligram. So the first step is to take a sample and to weigh it. Before weighing, you should see that the reading on the weighing balance should be 0. This is we call as tear. So that there should not be any air while taking the weight of the sample. Then you put the sample here as shown in this picture and note down the reading. Here in this case it's 1.7036 gram. That weight we call as a WT, and that is equal to WF plus WM. WF is the weight of fiber and WM is the weight of matrix. Right, so in this experiment, first you have to find out the weight, individual weights of fiber and matrix. Then you have to find out the volumes of fiber and matrix, and then from that we can find out the void fractions and fiber fractions. In the second step, you have to take the sample and you have to measure the volume by using vernier caliper, and that is by this formula VT, that is total volume equal to length into breadth into height. So this is a picture showing measurement of the length, and in this picture you can see measurement of the width. The reading of the vernier caliper will be equal to main scale reading plus vernier scale reading into least count. The total volume of the specimen can be written as VT equal to VF plus VM plus VV. Here VF is the volume of fibers, VM is the volume of matrix, and VV is the volume of voids. The volume of voids will be negligible because voids will only have air in it. So we cannot calculate volume of void by any measurement. We have to find out first the volume of fiber and then volume of matrix. From that only we can find out volume of voids. In the third step, you have to put the sample into the furnace at about 800 degrees Celsius. In this process, the epoxy or the organic resin will evaporate and it will leave only the glass fiber. So you have to take the sample into this crucible, and using this stone you have to place the sample into the furnace. In this picture you can see that the temperature is around 745. The interior of the furnace has become red hot here. In the fourth step, after keeping at 800 degrees Celsius for 10 to 15 minutes, let the furnace cool down. Let it reach to 200 degrees Celsius. Then take out the sample. The sample now will look like this. These are only the glass fibers because the resin or the polymer has already get evaporated. Put these glass fibers on a weighing balance and measure the weight. In this case, it's 0.3430 gram. Now, the weight of the sample after burning, that we call as WB, that is equal to WF. Means whatever the weight of sample after burning is equal to the weight of fibers because polymer has already evaporated. If you use this weight of fiber, that is WB, you can get the weight of matrix. Wm equal to Wt minus Wb. Now you have weight of fibers and you have weight of matrix. And you also know the density of fiber, that is 2.5 kg per cc, and density of matrix, that is 1.12 gram per cc. Using the weight and density, you can easily find out the volume of fiber and the volume of matrix. Now if you subtract this volume of fiber and matrix from the total volume that we have calculated using length into breadth into height, you can easily get the value of void volume. In the last step, you have to divide the void volume by the total volume and the fiber volume by the total volume to get the values of void fraction and the fiber fraction. And as I have told in the theory, that void fraction should be less and fiber fraction should be higher for good mechanical properties. Now you can go to the LMS and download the data and find out the values of void fraction and the fiber fraction. Good luck. Thank you.